Hello, my name is Miss Doreen, and I'll be going through lesson 3.3, which is optimization examples. So this is the final topic for this unit 3 that I will be teaching you. So mainly what you need to know is the type of optimization problems that you'll be encountering. So the main three are going to be design, economics, and biological sciences. So to basically give you a brief summary, design will involve usually volume, area, and perimeter. Economics will involve profit, cost, and revenue, and biological sciences will involve the concentrations on medicine, bacteria, etc. So I gave you a brief step-by-step tutorial on how to solve it, but it is a lot of words, therefore later on I will guide you through it. So first, you'll have to read the problems carefully and identify what you are looking for. So labeled diagrams can be helpful depending on the question. So for example, if it was a design question, it will be helpful for you to draw it out. Whereas if it was a bacteria question, it will not really be necessary. Then you have to choose the variables and set up your let statements. After that, you will have to create an equation to be maximized or minimized depending on what the question is, and express it in terms of one variable. You'll have to take the derivative, set it to 0, and solve for the variable. And this sounds very similar to the finding the extreme values, which we have learned in 3.2. We will then determine the domain of the function if it is not given already, and then we will use the critical numbers and the domain endpoints that we found to find the absolute maximum and minimum value. And then we have to lastly write a concluding statement, and this is very important because these are all word problems. So, even though I gave you this step-by-step tutorial, it is still very important to practice. Word problems are really complicated, and even though I will be going through 3 main examples with you, there are still a lot of variations of the same topics that you will have to go through yourself through the homeworks and the quizzes and the exams that I will be providing for you. So let's start off with the first question, which is a design question. So a cattle rancher has purchased 4 100-meter rolls of fencing to build a rectangular corral, one side of which will be formed by a barn. She will use all the fencing. What dimensions of the corral will produce the greatest possible area? So I've drawn a little diagram for you here, and this will be very helpful in, let's say, your homeworks or your quizzes, for you to draw a little diagram when it's a design question. So I wrote my let statements, which is let W represent the width in meters and let L represent the length in meters. First, you have to find the perimeter. I wrote P equals to 2W plus the L because we have to calculate for 2 of the width and only 1 of the length because the barn will be on one side. So then we plug in 400 meters because she said 4 100-meter rolls of fencing will be used, and all of it will be used. So then we isolate to find the length, and we have L equals to 400 minus 2W. Then we have to find the area. The area, as you know, is length multiplied by width, and since we already isolated for the length, we subbed it in, and then we expanded this, and we got negative 2W to the power of 2 plus 400W. Then we found the derivative of the area, and we got negative 4W plus 400. We set the derivative to equal to 0, so then we can isolate to find for our variable, which is W. So then we ended up finding that the width is 100. By finding the width, we can sub it into the length formula that we found, and we found that the length will be 200. We know that our domain is going to be your width has to be bigger than 0, but it also has to be smaller than 200 because 200 is the length meter. So then you will have to plug all your values, your 2 endpoints and your x values, your critical values that you found, into your area. And by plugging it in, when the x is 0, you will get 0. For your area, if you plug in for 200, you will get 0 again. But when you plug in 100, which is your width, you will get 20,000. So this is your greatest area. So then they're asking for your dimensions, and so you have to put it in this format here. So 100 meters times 200 meters will produce the greatest area. Okay, now moving on to an economic question. The profit of a laptop company in thousands of dollars is given by the function p bracket x equals to 0.01x squared plus 8x plus 3,000, where x is the amount of money spent on advertising. Determine the maximum profit that the company will earn through advertising. It is very important when you see these types of questions to note that it says here in thousands of dollars. So I'll tell you why later. So first, we have to find the derivative of the profit, which they gave you the function here. So then you will get 0.02x plus 8. You set the derivative to equal to 0 so that you can find your critical number, which is negative 400. You plug in your critical number back into your original function, which is I've done already here for you, and you will get 1,400. Remember when I told you, it said here, the profit of a laptop company in thousands of dollars. So we're not done here. We cannot just leave it like that. We have to multiply it by thousands of dollars. And then we will get this number over here. And that is our final answer. And remember to write a concluding statement at the very end, because that counts for your communication mark, and it is very important in optimization examples because it is word problems. Now finally, let's move on to the biological science. The concentration in milligrams per cubic centimeter of a certain medicine in a patient's bloodstream is given by the function C bracket T equals 625 minus 200T plus 25T squared, where T is the number of hours after the medicine has been taken. What is the maximum concentrations between the first and fourth hour after the medicine is taken? So simply by looking at this question, you know that it says first and fourth. There gives you your domain. So your time has to be bigger than or equal to 1, but it cannot be more than 4. So it's the same as always. You have to realize that later on, while you're doing more of these optimization examples, it is basically the same steps over and over again, but it's written very differently. So I would really advise you going through all the examples that I will give you later. So you find your main function and you find the derivative of it. So I've done it here for you. You get negative 200 plus 50t. You set your derivative to equal to 0 so that you can find your critical number. And your critical number here is going to be 4 equals to t. You plug in your critical number back into your original function, and which I've done here for you, and then you will get 225. But you also have to remember, you have to plug in your endpoints given by the domain. And because 4 is equal to the 4 that's given here in the domain, you don't have to do it twice because you'll get the same value anyways. And then you have to plug in 1 here, which you'll get 450. And you compare the y values, which is the same thing we've learned in 3.2, and then you will find that writing in your concluding statement, the maximum concentration is 450 milligrams per cubic centimeter at the first hour, because the x value here is 1, after the medicine is consumed. And like that, 3.3 is over. So again, it's very simple, or this is not very complicated, and I hope that you can all go through the practice questions that I will give to help further your understandings, because the questions do get a lot more complicated than what I have taught today. Okay, thank you.